Years ago, I worked for USA Today as the weather editor for the newspaper, and someone had sent in a question about the terminal velocity of a snowflake. And I thought it was an interesting question, and I wound up doing a graphic which compares the terminal velocities of various objects, in this case a snowflake, a raindrop, and a skydiver. Now I want you to understand why they have different terminal velocities. Remember, terminal velocity is the speed at which an object is falling, at which point its air resistance equals its weight. So let's take, for example, a little snowflake. A snowflake does not weigh very much, right? So if I wanted to first of all, when I first drop my snowflake, think about the forces acting on it. Well, the snowflake does have mass, and therefore the Earth does pull on it with a force we call weight. However, that weight is tiny. But it is going to accelerate. Initially, the weight is the only game in town when the snowflake first starts falling, and therefore it's going to accelerate downward. However, once it starts to accelerate downward and pick up speed, it's going to start running into air molecules, and it won't take very long for it to be running into enough air molecules that the upward air resistance is equal to the weight. In fact, I'm going to label it as FR, force of resistance. And notice right now I've got a net force of 0. If I add the weight and the air resistance, I've got a net force of 0. I will have reached will have reached terminal velocity for the snowflake. Notice I don't have to wind up going very fast. 1.5 miles per hour is as fast as the snowflake has to reach before its air resistance equals its own weight. Now, raindrop, on the other hand, a little drop of water here, a little more massive and therefore weighs a little bit more. And therefore, because it's got a greater weight, it's going to have to fall faster or be much bigger in surface area. But in this case, it falls faster in order to hit enough air molecules so that the force of the air molecules hitting the raindrop equals the weight of the raindrop. But eventually it will. It'll fall fast enough that the air resistance will equal the weight, and that will also be terminal velocity. So for the terminal velocity for raindrop, around 14.5 miles per hour. For a skydiver, I'm going to draw my little guy here. Let's do him in purple. So here he is, beep, beep, beep. Weighs way, way much more than a raindrop or a snowflake. So when he first jumps out of the plane, it's his weight that causes him to accelerate. For an instant, he's in free fall. However, he won't be in free fall for very long, because once he starts falling, he's hitting air molecules. Once he hits air molecules hit him. We have air resistance, but he's going to have to fall really fast in order to hit enough air molecules so that the force of those air molecules hitting him, and in fact I went off my page here, is equal to his own weight, at which point we call that terminal velocity.